Have you guys heard of the external transfer switch? So that solution, this is the solution we have for the Multiplus 2s, 5, 8, 10 and 15 if you want to do parallel and you want to do big systems. So this is the old school solution. Yeah, we have our quattros or our multipluses. We have the generator or the grid. We have our input switch gear coming into each one. And then we have our outputs going to the output switch gear to the system. Right? The problem here is, well, it's not a problem, but the reality is that every multiplus in the system, the internal transfer switch will operate. And the communication between all of them have to communicate so they all switch at the same time. And depending on the loads, the power factor, how clean the power is, and reliability, over time, that gets worse, which means the relays operate. Yeah, they take strain. They can only do so much. And that's usually the first thing that fails. So that's why we've developed the external transfer switch topology, and that's what all the big guys are doing. If you do a data center or an N+1 system, they all have a common AC bus, and everything connects to that bus to supply the load. So you have generators and grids and multiple generators. That's how most of the guys are doing it. So, which is interesting, it's not what's the word, voodoo, or the black arts that's used by a lot of people. And the whole idea is to reduce the wiring, the switch gear, because the Multiplus 2s already come at quite a nice price advantage. So now you can go this way and offer something a little bit extra. Now, yes, to improve the longevity and seamless high power switching. So there's the external transfer switch. I've been to a couple of switchboard manufacturers. I've given them a spec. They've designed the box. They've given me a quote on these boxes. I've been to 2 in Cape Town. I have it. It doesn't look that expensive. And it's a switchboard manufacturer. And that's basically what you want. Oh, I want a 100 amp transfer switch. White box, it gets delivered. You don't have to go build it yourself. Because that's the big thing. This is all very nice. Where are we going to get it? What is the spec? So that's why we went this way, and I thought that's very interesting for you guys. If you have a project and you need one, you can just contact the manufacturer, say, I need this, and delivered 2 days later. That makes sense, eh? Because the labor is the problem. Those guys just pump those things out like... So, all these Multiplus 2s, how it works is every master, and it's only for 3-phase, unfortunately, but every master has to measure the input voltage and current. So to measure the current, you use the CT that you buy with the Multiplus 2. It's either the 100 amp or the 400 amp. I've got a 400 amp model here. So let's see who does lots of big systems. That's the CT there. It's the 400 amp CT. You don't touch it. You can see a problem with, and you can open it, of course, open, close, clamp it, but 400 amps. Yeah. 3-phase. Per phase. What's the total system size of that? Quick numbers, maths. 250 kilowatt. Okay. We must do the math, but.
Thank you for it.
Yeah. Small, eh? Okay, so there's another solution to use another type of transformer. I've seen some chat on that. If you want to do, so you can replace that. Basically, that connects to each master, measures the current, and then the AC input is connected to the input with a thin formal cable just to measure the voltage. And that tells the system to close the transfer switch to connect to the grid or the generator. Okay. So this is from the manual. It gives you like an exploded view. So there you see, there the CTs and this very thin voltage measurement for the input. That's the AC input. To do the voltage sensing from the supply. Ground relay. So we use the internal ground relay mechanism as 200 milliamps. So here you need a help relay. So it operates on 200 milliamps. It switches another more high-powered relay. Because the bigger the power, the bigger the ground relay must be. Hey? So that's why that needs to be there. And this is the external transfer switch here. So here we can see transfer switch to 30-volt coil, driven by the Multiplus programmable relay. And that's obviously the power breaker to switch power on and off. For the output, servo. Yeah, external transfer switch. Originally, when we started with this, we only said you can only use this one. That one over there, the 4-pole, bigger, very expensive, 35,000 Rand contactor. But after a lot more testing and that, we can now confidently say you can use any high-speed, high-power contactor with that specification, 230-volt coil. Okay. And in the manual, it tells you what the spec is. Yes, Warwick.
Andre, there was a discussion at the distributors meeting last year in Cape Town about this. And it was at that meeting where someone in the audience made a comment on the case, and then there was some thinking on the floor, and everyone realized that it didn't really matter about having this super duper expensive high-speed contactor because of something.
I know who it was, yeah.
What is the something? I never caught that reason why the transfer time is,
The transfer time must be under 50 milliseconds.
Yeah, so it was, according to the transfer time, they said it was only Schneider that's capable.
Yeah.
And they said it's not just Schneider, it's ABB, Socomec, areas of range.
Okay.
And they came to a conclusion.
Even Levato, there's a lot of
We can use any contactor because all of them, it's the similar time. Levato and
So-
Socomec, 10 seconds and not 20 seconds.
So what happens is the multis sense the power here, then they send a signal for this to close. And if that takes longer than 80 milliseconds, they switch off. Because that's too slow to connect and transfer power. That's the issue. So the quicker that can connect, 80 milliseconds is like the absolute maximum. So find something that's faster and it'll just work.
And you're also limited on to the distance between the external transfer switch and the inverter.
So that's just a coil with 30 volts.
That's the limited point.
That's
So you only need the external switch to the multiplus, not the quadrants.
the quadros you can't use as topology.
Yeah.
It's different topology.
You use we do it this way.
Yeah.
Well, that's what I'm saying. You only need the external switch on the multiplus too.
You can only use it with the Multiplus 2s, 5, 8, 10, and 15 for larger systems. 45 kVA,
Control and
60, 90.
Okay, so it's not available for.
So this is 400 men.
Quadros, no.
It's not that you need it, it's that in the absence of the external transfer switch, you're relying on potentially 16 in the case of the Multiplus 35 kVA. How many is it maximum?
12.
12. But the 5s is more.
Yeah, well.
You're relying on 16 of the individual relays, which are electromechanical, to all close or open at exactly the same time.
Yeah.
And if they don't, then one of them will be carrying more current than the other. And as the voltage fades, that current tends towards infinity. So the relays take a lot of strain. So the solution is have only one thing that carries the way it changes.
And also, a very big thing is that the AC output becomes bidirectional. It does both jobs.
Mm.
And that's a future topology for us. A lot of our newer systems in the future will have only one AC connection, not two. No input and output, only one. And it's bidirectional. So this is the first step in that direction. So for you guys to start looking at it, getting used to it. Like I said, I'll try to get access to some sites where we can maybe do a site visit and show people Sync Energy, this is what they are. Yeah, we have seamless integration and switching. They use this.
Mm.
A lot of the bigger guys, they use this. Okay. So it's not an issue. It's a nice solution. It's just to do the financial calculation. And the nice thing is if you use Node Red, you can use the generator and the grid. And then configure the system depending on which AC input source you're putting into it. So you can really build a very nice solution. Okay. It's not a problem. It's a really a nice solution for larger systems. If you really compete with in the 60 to 90 to 120 range, again, you can say, look, on price, there's a very nice solution. How you engineer it, they don't need to know. It's just on price you can now really compete, and it's much more reliable than it was before.
Off topic, who still uses ATSs, or do you guys use more mechanical interlocks? ATS. And failure rate?
No.
So
We'll see.
there's many ways to use it. Yeah. I know guys that actually build the external transfer switch into the ATS as well, because this is not. There's all enclosed in one. But that's the flexibility of this. Okay.
Just out of interest, can the Hager contactors be used for that?
Yeah.
Okay.
I don't know,
Yeah, he said yes.
but he hasn't tested it yet.
Well, it's I spoke to
We don't know which model, so yeah.
yeah, the top circa.
Well, depending on which model, we don't know which model, so they must have something that can work. Yeah. But you know, the idea is at the Joburg Solar Show, I asked the guy to build a box with all the Hager components, and it was there on display with the whole external transfer.
That's no problem. Let's see, use it.
Yeah.
Only Hager.
That's what I asked him to do. I still have it actually somewhere in one of the warehouses.
That's not
I see it.
Okay.
But it was over-engineered a little bit. But anyway, that's fine. So that's the 400 amp I showed you. Yeah. That's for the bigger systems.
Some from inside.
So what's that?
I think you had blue lights inside or something.
Yeah. Of course, to light it up. But I know of people using other CTs that are much, much bigger. I've seen something on one of our chats, so I can share that if you guys need something like that.
You can use polybraid. You know polybraid. It will fit in this hole with a bit of Vaseline.
Unless you have a system with a bus bar. Yeah.
Otherwise,
That's the
you need,
reality. So in the manual, there's a very nice manual that tells you how the V-bus configuration must work. It tells you step by step how to do that, how to configure it, the masters, the slaves. You must select your current sensor in the master. Yeah, very nice. So in summary, suitable for off-grid, grid-tied, and systems with generators. Works with Multiplus 2 single-phase models, supports one AC input, but with no grid, we can have multiple. AC power, source rating is 100 or 400 amps. Those are your two selections. You can have a 50 amp input, but then you use this CT. Make sense? Okay. Requires specific V-bus firmware for that. And the manual is actually very, very nice. We actually uploaded a big schematic about it as well a little while back for generator systems. Okay, so that's interesting.
You said it's 3-phase only, not parallel.
Yes. Okay.
But then it takes the system to maximum of 16 of the big ones, of the 15 Multiplus.
The normal limitation.
Did you say 16, Warren?
No.
5, she said.
But the manual says you can
It's
use
not 16 either because it's not divisible by 3. So,
Doing the right one will do 60 units.
sorry, Walter.
How much is
So it's a good question.
I thought the manual said you can use it for parallel.
Not for 3-phase. Sorry, not for single phase.
Okay,
Not for single phase parallel.
then I got that wrong.
Yeah, no, it's not for single phase. Trust me, I have lots of issues in other neighboring countries where guys are doing it, saying like this. Yeah, can't. No, look, it works. I've got a lot of guys that got a system that works, but eventually those relays fail. And you sit with that problem. So, yeah. Okay.
So why can't you parallel two multis with an external transfer switch, but you can parallel the 3-phase?
It's not, we haven't developed it for single phase yet.
Okay.
It's coming.
Yeah, but the manual is different. So
No, it's a good point because I've spoken to the guy that writes the manuals, and I'm sure Warwick will make a note and also talk to him. But we have to,
someone asked
it has
on
to be
the group,
redone.
I think last week, if you can parallel two 8 kVAs.
Look, it works,
Yeah, okay.
but eventually you're going to have a problem, and that's why we say it's not supported.
Okay.
But you're right, the documentation does need to improve.
Yes.
Well, we have several systems, single phase systems, 1 5 kV multi, and when the grid goes off, the lights, some of the lights go off. So this might, if it's possible for single phase, you can actually run your system like that. And just have it always on. So it's almost like online your desk.
Yeah,
Output
yeah, exactly.
connected with
Yeah.
the lights. And you just switch your
Yeah. I'm busy with the project now also for like an online, you with 2-3 kVAs. If it's off grid, Walter, if it's off grid, you can parallel them because then you're not interacting with the grid. So then you can parallel them, there's no problem.
who uses 3 kVAs a lot?
No one. They all use 5 kVAs.
Is it better to have
Multiplus.
Is it better to buy or have three threes? Less cabling with that 8.
Yeah, of course.
It's the fuse cost per labor that kills you at the end of the day.
It's like 2 5 kVs is better than one thing.
No.
What is the update for more than 180 kVs for Victron?
It's a little bit early to talk about that.
by EMS. And you can have multiple 180 kVs.
But there's a microgrid topology we're working on. It goes to many places, many nodes, whatever that is.
Mhm.
You know, that's consumers, could be a factory, could be anything. And the idea is in the future that we have
I like that.
So we'll have a solution that will just connect to the grid, and the grid controls what it does. So no GX device, it gets grid controlled, telling it to either charge its battery or discharge its battery. Okay. So that's the basic topology for the future. And of course, if you use Node-RED ESS, I mean, yeah. I'm working on a project now with a big company where we're doing something like this, but we're using they have EMS control system. They talks to each one. We're really doing it. We've really launched the first couple of, it's happening. And that tells them all what to do according to time of use, arbitrage. Well, that's CAN bus. Yeah, but there are lots of different protocols. The big thing with this, of course, is you need reactive power. It needs to be in sync with the grid. The grid needs to be stable. And in these topologies, in places like Europe, you'll have something like this, but you'll also have generators connected. Multiple generators connected to the same system. So the system will start the generator because you have a limit here. And the EMS will say, look, hey, run this generator now because batteries are flat or whatever. Charge the batteries. That's a microgrid thing. So that's where we're going. So with the grid becoming more stable, there's a business case for that for the future. That's why the external transfer switch is so interesting. We need to start thinking about it, adopting it. It's coming. Okay. And the idea is, so the project I'm working on at the moment, there's an EMS. But our feature is that you wouldn't need an EMS. Because that will just automatically be, the communication will come from the grid, telling it to charge or discharge. And then, there's other parameters. So very exciting. Now that can be 30 kilowatt, can be 180 kilowatt. Where do you need the power the quickest? It's like this one needs double the systems, needs quick power, shortest route. This one just needs to supplement those two legs. Yeah, it makes sense. Okay. And with all our newer products, the larger products, I didn't talk about that. I'll show some slides now. The high voltage will all have this topology in the future. 48 volt is much quicker and easier to install. You don't need health and safety, complicated. Yeah, if you do high voltage systems, you know what that all looks like. How many files do you need to submit?
So high voltage.
High voltage.
They need to have five health and safety, obviously, fire extinguishers all around. I read that through the article, there needs to be a engineer signing the fire assessment. Well, I don't know how many of you guys installed. Yeah. So I don't know how many guys installed HSTs. And how's your assessment on your cycle?
Our biggest project was the Canadian project with Victron. Our portion was 1.5 million.
Yeah.
And that's in your 50 volt.
Yeah. That's where you came from your question. I
That's
know about it.
it's a way of avoiding the fact that we don't do it on our own.
So a lot of people is going that route for more decentralized systems, not a centralized system. So having a microgrid system installed instead of one big system and one single point of failure. So that's a big advantage.
There's pros and cons.
Yeah. Well, there's pros and cons of anything. Depends on how they want it. So a lot of quantity surveillors or new developments wants decentralized system and each different system.
But then you feed bi-directionally stream up.
Yeah, unfortunately.
If you, with the setup, obviously, like relay 1, you can set it gen start stuff, but then relay 2 is normally just a manual. Can you set up 2 gen start stops on 2 different
Generators.
two different like state of charge conditions? Like if you're running 2 separate generators from one GX, is that possible?
No.
For start stopping, yeah.
No, wait, he wants to ask on the internal gen start slots. Can you do 2 gens?
No, he's talking about the IO extender.
Yeah, so with your server and I extended,
I would
2 separate generators that need to
doing 2 different things.
do 2 different things running at 2 different times. You can run that from here.
No,
Using because the battery state of charge,
Yeah,
it's very difficult to move between to get.
Well, it depends on, yeah. And so what we would do is you'd use the normal generator start stop in the servo,
Yeah.
and then you'd program one of those to do basically what that's doing with Node Red to give you that functionality.
But your external
then-
wiring on the AC side will need to.
It was 2 different systems.
Yeah,
It's just one server that's.
Yeah,
But then what you can also do with Node Red is that Node Red you can build a little dash. Well, you don't have to have that because you'll have the on-off, the override
2
function.
separate on-offs with 2 separate conditions.
correct.
USB port, so you use one USB port.
On your GX, yeah.
And that brings us to the end of this video. If you've made it this far, I sincerely hope you have enjoyed the content and learned something new. If so, please leave a like and subscribe to support the channel, as well as to get notified of any future videos. Oh, and make sure to check out this video as well. You can also subscribe over here. And this one is pretty cool too. Lastly, don't forget to visit and sign up for a free account at the Blue Power Pro Forum.